Welcome to solverfy.
Okay, so in this question, we're looking at an ideal polarized filter, or Polaroid filter. And the question is, why will an ideal Polaroid filter transmit 50% of incident non-polarized light? Okay. Well, first off, let's look at what non-polarized light is. Non-polarized. So non-polarized light is a type of light beam that contains all waves that vibrate in all possible directions. So a non-polarized light beam or light wave is a wave containing all possible vibrations in all directions. In all directions. And remember, these directions are going to be perpendicular to the direction that the beam goes, aka the direction of propagation. Whenever you have a polarizing filter, this will only allow certain light waves or certain waves that vibrate in specific directions to pass through. So in order to transmit a non-polarized light, you'll only get one component of the electric field. One component of the electric field that is aligned with the filter's transmission axis. Filter's transmission axis. Now, mathematically speaking, we have an intensity relation, and typically the intensity of your light goes as like the electric field squared. And for non-polarized light, if the total intensity is I sub 0, the components along any direction, whether that's EX, EY, EZ, will always carry half of that intensity. In other words, IX, which might equal IY or IZ, would be half of your incident intensity. So, the amount that would be transmitted, I transmitted, will only be I sub 0 over 2. In other words, the component of the electric field must be aligned with the axis to go through, and you'll only get half of that intensity.